core image lets us make a QR code from any input string and do so very efficiently. However, there's a problem. The image it generates for the code is tiny, literally as big as it takes to draw the pixels of the QR code, black, white, and so forth, and no bigger. Now, it's trivial to make this thing resizable to be much, much bigger, but to make it look good, we have to adjust SwiftUI's interpolation, because by default, it'll stretch the image and blur the pixels to try and make it look better, which does not work well for solid colors like a QR code. And so in this step, we're going to ask the user to enter their name and email address into a form, then use those two pieces of information to generate a unique QR code describing them that someone else can then scan easily, without making the QR code look fuzzy, of course. Now, we already had this little placeholder me view we made earlier saying hello world. So our first job will be to go ahead and upgrade this to add a couple of text fields with a string binding behind them. So we'll say, first, there are some properties inside here. We'll do @state private var name is anonymous, and then @state private var email address will be you@yoursite.com. Now, when it comes to the body of the view down here, we're going to use two text fields in here, but we're going to attach a small bonus modifier called text content type, and it'll tell iOS what kind of data will go into these fields. And this is important because it'll allow iOS to offer autocomplete options for the user. It knows their name and their preferred email address, so it can fill them in with single taps. So inside here, I'll say it's a navigation view with a form inside, then a text field. We'll put name as a prompt, bound to the text of name, with a text content type, that's the new modifier, of .name. Then a font of title, a bit bigger by default. Then a text email address with text $email address, text content type, email address, and then font title again. Oh, hello. And with that field, also text field here, and then we'll add a little nav title as well, so it's more clear what screen we're on. So we'll say .navigation title. Yes. Nav title dog treat, huh? Sorry, real fast. The dog is needy, never gets fed. There you go, got you. That's just you get one kiss for a treat. Anyway, nav title will do your code. It's fine. Okay. Now we're going to use the name and email address from here to generate a QR code, which is a square collection of black and white pixels that can be scanned by other phones and other devices. And Core Image actually has a filter built in for this to make QR codes dynamically. And as you've learned how to use Core Image filters previously, you'll hopefully find this works very similarly. First, you want to bring in all the Core Image filters we care about. So we'll say import Core Image.ci filter built-ins. Second, we want to also bring Core Image itself in to access to all its built-in types. Then we're going to add some properties inside here to store a Core Image context where it generates the image data, but also a filter, the QR code generator filter. So we'll add these two to MeView. Let context be a CI context, and let filter be a CI filter dot QR code generator. Now for the interesting part, which is making the QR code itself. Now, if you remember, working with Core Image means we've got to provide some input data, then output the CI image to a CG image, then a CG image to a UI image, and then render it somehow. We're following the same steps here, except the input for our filter will be a string, ultimately, the name plus email address, but the filter expects to be given data, not a string, but some data. So you've got to handle the conversion between string and data behind the scenes. It's fine, we'll do it here. If the conversion fails for some reason, we're going to try and load the xmark.circle symbol from SF Symbols. And if that can't be read, which is theoretically impossible because it's going to be there, we'll send back an empty UI image. So we'll make a new method down here after our body property called generate QR code from string, a string, and send back a UI image of the finished thing. So our filter has a message value here, and again, it expects to have a data passed in, not just a string. So I'll say data string.utf8. That converts our string data into a data object, which then of course can be expected by core image. We'll then say if let output image is our filter output image, so we can read the one from our filter output image. There we go. And if we make that to a CG image, if let CG image equals context.create CG image, and we want that one there, so I'll say from our output image in the rect output image.extend, so the full size of our image, just like before. Then finally return a UI image from the CG image of that CG image, like that. That's the same thing we had before in I think InstaFilter it was. If that fails for any reason, we'll attempt to send back a UI image using system name xmark.circle, and if that fails, an empty UI image. So we've got multiple failure handlers here. Obviously, we hope this one here will work. Honestly, I think it will always work, but there you go. Then if that fails, attempt to use the SF symbol. And if that fails, just an empty UI image. Honestly, that's never going to happen, but we're just covering all possible options here. Now, isolating this functionality to make a QR code in a method works really well in SwiftUI because it means we can put code in our body property here just to handle layout. It stays as simple as possible. There's no QR code core image logic in here at all. In fact, we can just say image UI image and call generate QR code directly. Then scale up to whatever size you want to have. And it'll make sure that method is called whenever name or email address changes, because they are state. It'll reinvoke body, and body will call generate QR code. Now, in terms of the data to pass into this generate QR code method, you see it expects one string coming in here. We're going to use the name and email address of the person separated by a line break. This is a super simple format. It's a nice and simple format to work with because it's easy to reverse when we scan QR codes. We'll get line 1, line break, line 2. So we'll know name, email address. Always. It's a fixed format. Anyway, we're going to add this new image directly below the second text field. So we'll say as an image using UI image, generate QR code from the string, name, line break, email address. Both those things. I'll make it resizable and scale to fit, just in case it comes out an unusual shape. Then give it the frame width 200, height 200. And that becomes our new me view. It's a way to type in a name, email address, and say your QR code. So over in the me tab now, that's our QR code. So it's working really nicely. And of course, you can just type in something here to change that. If I said, my name is Paul Hudson, whatever, it updates as we're typing. It's an extremely fast filter. However, I'm not sure you can see it in my recording, but hopefully you'll see it in your code when you run it in the simulator. The QR code is blurry. It's fuzzy because it's actually making a really, really tiny image and then just stretching up. And we do that, SwiftUI is trying to smooth out the black and white pixels to make it look better, but it actually makes it look worse. And the simple truth is that line art, like QR code, doesn't work well with image interpolation. And so what we really want to do is say interpolation, none, after resizable. Do not use the smoothing algorithm with this particular image here. If I run it again, we should see the same kind of QR code, but looking much, much better. There we go. Pin sharp now. That's how QR codes ought to look. Blocky is the design, how it's supposed to look. Because SwiftUI will just repeat pixels, doubling up, tripling, quadrupling, whatever, the pixels. Lots of blacks, lots of whites, whatever, as opposed to trying to blend them neatly. I'd imagine within reason that cameras don't really mind which one gets used. It might struggle slightly more on the blurry ones. It looks like it's out of focus, but it does look better to users, and that matters.